Dubai. And we'll be talking about some of the work that LTC is doing with cores in that area.
Yes.
Simone.
Hello everyone. Just 1 second. Can you see my screen? Yes. Okay. Okay. This one here. Hello everyone again. Thank you for joining the event. So today we are bringing a big topic from our own analysis, and the topic is the study of the evolution of the transformer core design and the GOEs. So as a LTC, we take all our data and analytics to make a study of over the trend worldwide, and we focus mainly in 2 markets. So I will start with our own introduction. So why the importance of the efficiency in the transformer and how is defined the efficiency in the transformer? So the main information that we consider nowadays is the peak efficiency index, and this is defining how much is the transformer performance during the work. And several years of implementation brought these formulas more and more complicated, so nowadays the efficiency is taking in account several data from the no-load loss and from the core loss, and as well from the electrical copper and winding. So all those information make the total efficiency of the transformer, and we can say that in distribution and power transformer the efficiency is a little bit different, but we are already speaking of transformer equipment which are having an efficiency between 95 to 98% in the small distribution, and in the power and high power it can reach up to 99.7%. We took as a reference to also show this distribution of the losses, the eco-design regulation that is showing that the total loss of the transformer is made by the core loss and the winding loss, and these losses are the load losses are basically 89 to 92%, and the load losses of the core are only 8 to 11%. So our focus now will be on the study of the core losses, and we can see why it's important to improve. It's important to improve because we can see in the last 60 years the trend is that the energy demand is growing and growing, and the last measurement of 2021 is showing that the global demand is 1,500 million terawatt hour, and this value is going to increase. So the focus of everyone is how we can achieve better performance, how we can make the transformer more efficient in the future. And we made some highlights, so we can see everyone is focused in reducing the carbon emission, and how each country is doing this job in a different way. So we can see that Europe is one of the first which start big requirements with eco-design starting from 2015, and the new regulation is already starting 2021. We can see also from other countries like Australia, they develop some minimum efficiency levels start from 2004, so a long time ago, and they made some improvements in the time, including also additional efficiency requirement. The same is with USA, that they are studying, the Department of Energy of USA is studying for new regulation, and the idea is always to enhance the grid power and reduce the carbon emission. We can see also a big player that is China, that is having a very high demand in terms of energy, and everyone is studying each own plan. In China they are doing a 5-year plan, and now the plan is to reduce the carbon emission by 1.5 billion by 2030. So it's the biggest one in the world, and also the one which is having the highest goal. If we go also in UAE it's small compared to USA and China, but we can see also the idea is to push with renewable energy, and the target is to be on 2030 as well to try to reduce the carbon emission by 70 million tons. And last but not the least, we can see Japan. In Japan also the Energy Conservation Center is studying constantly how to improve the efficiency for every kind of equipment, and for the transformer, the idea is to increase the renewable energy up to 36-38% by 2030, and the same also for the carbon CO2 emission. The idea is to aim to a reduction of 930 million tons. And we can see why we start with the goal of everyone, because the idea is that in the future we want to have a green grid. So everyone will be having a green life, and how we can achieve the green life only if everyone is able to start from the renewable energy and make the whole process a green process. So we are speaking about transformer, we are speaking about electrical steel, and we are speaking about green electrical steel. In the future, the idea will be to have electrical steel green and the energy generation which is also green. If we will be able to achieve this goal, of course, everyone in the process from the generation to the last user will be a green life. And now we go a little bit more in the detail, and we can see from LTC perspective how the core design is changed to support the transformer efficiency and how the losses are reduced in the time. We can see we study from the last 1990s to 2024, and of course the idea is we go also in the future, and we can say we can have some forecast. The two important dates that we fix in our line is the regulation from Europe, so we can see the co-design tier 1 and the co-design tier 2. We do this analysis because in Europe we can see the trend, it's changing, and I think it's showing also interesting information for the other countries as well. And as LTC, we can see the focus is done in the last 35 years, as we have a big experience in the core manufacturing, and we took over 1 million of results to make our analysis. Now we go a little bit more in the detail. We can see the two markets that we took in analysis. We have the European market and the Middle East. In the European market, we can see the date starting from 2008 to 2024. We just took the last 15 years. We can see the first trend is the no load reduction, which is starting from regulation. And therefore, these regulations start to make a move in the design of the core. We can see the trend of the material is changing in the time, and the future is also having a forecast of other additional change. What we can see, so the materials trend, if we see about, we divide two main categories, so conventional grade and high permeability and domain refined grain. We can see that in 2008 to 2014 there was no European regulation, there was no any limitation, and the big consume was on the conventional grade, and the most two common grade were the M6035, or also 13535, and the M5030, so 12030. And in the laser and high permeability material, we can see that the most common was the laser 23 H8523. Just one step ahead, when we go into the tier 1, everyone had to make some change in the design, and we can see that in the conventional we have already 15% of reduction from the 2008 to 2015. And this reduction is showing that the trend is to make a transformer with lower losses, as is requested by the eco-design. And this made the chance to move from material like M6, T35 and M5 T30 to material like M4, T27 and M3 T23. And we can see that now the percentage of the second step is more into M4 and M3 for the conventional. Instead, also for the laser material, we can see that the hypermeability material is only a small portion of the consummation, and we can see that in the laser 23 we add a new grade because the market requests some lower losses, and therefore the manufacturer develops some new grade. And there is a big move from H85 to H80 and H75. And this is already from the Tier 1. If we move one step ahead in the Tier 2, we can see that the change in the consumption in terms of percentage from conventional to hypermeability and laser is not changing that much, but we can see that the average material that are now used are more into a lower selection for the conventional, that is now M427 with the losses of 105.27 and M323 of 95.23, so let's say a big step ahead. And for the laser material and the domain refine, so we can see the move is on the laser 23, 75, 23 mainly. So there are still some customers that designed which other grades, but we can mainly see in the two categories, the two grade M4027 with the selected losses and laser 23 with the 75, 23 losses. And moving ahead in the future, we can see the trend is always to reduce the no-load loss. So the trend is moving in the direction of having more and more hypermeability and laser-treated material. And we can expect by 2030 to say the demand will be and the consumption will be 60% in the laser and hypermeability material and only 40% in the conventional. This doesn't mean that the conventional will not be used anymore, and we can also see that the conventional is using more materials with lower losses, because the goal will be to optimize again the transformer design, the core design, and therefore the losses will be reduced to 1 watt kg 127 and 0.90 watt kg 9023. And we can see in the laser the two grades that are more common will be the 33% we expect of 7523, so the majority of the hypermeability material, and 12% will be lower selection of 7023. Now we can see how the design will change and how it's changing the time to support the no-load loss reduction. We can see in general the TÜV regulation put into account the no-load loss reduction, but how the customer are achieving the reduction of the losses is making changes in the design, and we can see a core increment weight of 20% in each step. So 20% in between the 2014 and 2015 with Ecodesign Tier 1, and after 2021 another 20% in support of the Tier 2 regulation. And another step is the reduction of the flux density, which we assume to be start from a high value. Now we can see in the first step it's reduced by 20%, and in the second step again another 15%. In combination, the two core increment weight and flux density reduction make this Tier 2 an easier and efficient transformer core design. Now we move into the Middle East market. We can see, as I said before, the two markets we took in account are the European market and the Middle East. In the Middle East, we can see that the big developments that the countries are doing are making some different trends in the material, because before a European regulation, there was a complete different scenario in the Middle East, and everyone was using a lot of hypermeability and domain refined material. We can see that the percentage is 64% on this grade and only 36% in the conventional, while we can see that after 2013, everyone moved into conventional more and more. And there are two reasons why they do this, because one, there is no regulation, and so they capitalize the losses in a different way. And the other is because there is a big developments in each country, so they prefer to push for the developments of the economy instead of having a reduction in the losses like in the European market. And they have the goal that we saw before also, that the goal is to increase the renewable energy and not focus only in the core losses. Now we move into, again, the detail of this trend. we can see we made some analysis and we have some case history. We took 6 different designs. We took 3 designs in the ODT transformer, so the oil immersed transformer, and 3 designs in the CRT transformer. What we will see that we have 3 different ratings in the ODT design, while in the CRT we have 2 different ratings, and we can see now. So the ODT design, the losses are the one explained and regulated by the European Union, and we can see how the losses reduce in the time. And focusing in the difference between the Tier 2 and the Tier 1 design, we can see that the losses are reduced by 10%. And in this case, the material keep the same material, so the grade is H8023, while the weight have an increase of 30%, and the fluxing density have a reduction of 16%. So what we can see from the data before the regulation and in the regulation Tier 2, we have a big increment in terms of weight and a big reduction in terms of the induction. All this is done to achieve a better result in terms of no-load loss. Then now we can see the case number 2. This is 630 kVA. In this case, again, we have a different material application, because we can see before the regulation the material was H85, and in the step of the regulation this changed to 75, so a lower grade with low losses. Again, the no-load loss reduction is 10% by the regulation, and we can see, keeping the same grade in between the 2 regulations, the core weight had to make a big step in 27% additional weight, and the induction, again, as we can see, a 17% reduction in the weight, in the flux density. And again, we can see these two cases, we have a big difference in terms of weight and the reduction of the flux density. And now we go to the case number 3. We can see that in this case is a 1000 kVA transformer, so we don't have data before the regulation, but we can see in between the 2 regulations we have again a reduction of 10% in the losses, and keeping the same grade, the transformer had to understand that we have 20% of increase in the core weight and a reduction of the flux density of 15%. So we can see at the end of these 3 cases in the ODT, everyone is pushing and changing the design of the core to reduce the losses, increasing the weight and reducing the induction. Now we go to the CRT. We can see it in the CRT type, so the cast resin transformer. We have 1000 kVA. In this case, the material is not anymore a laser material, but is a conventional material. And what we can see that before the regulation, the material, the most common material was M5030 with a specific loss of 1.20 watt/kg. And due to the regulation, there is a big step and big reduction in terms of losses between before the regulation and the Tier 1, and then in between Tier 1 and Tier 2 the change is, let's say, 10%. But what is the different here in the design is that the material is changed to use a selection of the M4027. So the material grade is basically the same in between the 2 regulations, but there is a step again in the selection because of the manufacturer losses and the design of the transformer. And we can see in this case as well that the core increment is a little bit reduced compared to the ODT type, but is still 12% increment. And for the induction, we can see again 8.5% reduction. So again, the trend is to change the design to a lower losses in the core design. Now we have another case, the 1000 kVA. Again, this is similar from before, same rating, but we can see the losses from the regulation is exactly the same. But the difference between the Tier 2 and the Tier 1 in this case is that this customer changed the grade from M4027, so from a conventional grade to a laser-treated material, and changing this to H8023. It's a big step, but also this allows to make a lighter weight in the core design, and so we have a 12% reduction. And at the same time, we can see we have a 12% increment in the flux density. So we can say in this kind of design there is an opposite trend, because the new grade allow to the customer to make a design which is lighter and therefore is also more efficient. And the last case that we have, the 1600 kVA, this is again another cast resin transformer. In this case, we can see the material was M4027 with the specific losses of 120 before the application of the first Tier 1 regulation. And we can see in the Tier 2 another again step of 10% in the losses, and in this case the material is still in the conventional field, but is moved to the M323 laser. So the losses move from 120 before the regulation to 95 in the step 2. In this case, we can see the weight is basically not changed from the co-design regulation, because there is only a small reduction of 0.6, but we can see also the induction is changing and is increasing again from the Tier 1. So what we can say again in this case, we have a trend that is allowing a smaller core design and making a more efficiency transformer. Now, one step into the future. So we see what is the trend till now, and we see how each customer had the change in their own design. If we go into the future, we can see everyone is working on three main things that are the sustainability, the efficiency, and the reliability of the transformer. And we can say in the sustainability, everyone aim to have green electrical steel, and the goal is to have lower and lower losses in the material. So therefore we say everyone would like to have a material grade with losses 0.6 or below. Then together with the core, we have of course in the oil field we have the green oil. So everyone is looking to use a new product, and the use of new oil like a neutral oil, Rister oil, will achieve better performance in terms of technical application, and as well we make sure to optimize the transformer design. And therefore the combination of these two, the electrical green steel and the green oil, will make the possibility to move into the green transformer. So everything will be green and everything will be eco-friendly. Then we can see another step is the efficiency. So everyone wants to increase the efficiency of the transformer, even if we say the transformer is already a machinery with high efficiency. We can also increase the efficiency of all the accessories of the transformer, and let's say the cooling fan for the CRT application, or we can see also to implement the predictive cooling for both CRT and ODT application. So there are a lot of companies that are studying how to implement this in the product. And we can see also the reliability, so the increase of temperature resistance of the accessories like material, like insulation materials, will allow to have a transformer that can work with higher temperature and therefore can maybe have a higher load. And this will make sure that the equipment will be lighter and eco-friendly again. And let's say also another step is the online monitoring, because if we can connect every transformer to the grid and we can monitoring the energy that the transformer is taking, we can see also how to make the grid more efficient and balance the load in the line. And now we can see, let's say, this is probably the step that everyone is doing to have this vision of 2030. Next step is 2050. And on this step, let's say 20 years is a big step ahead. And right now, we don't have any answer. We don't know what will be coming in the future. But what we can expect is that more and more everyone will look into these details and will try to optimize more and more the machinery. And that's the end. I will say thank you for your attention. And if you have any question.
First, like comments about the future 2030, that you see the vision of core losses less than 0.6 per kilo. Yeah, that's very challenging. So
yeah.
I think people in this room would say, wow. My question is instead, what about the noise? Because I noticed that you are using a strategy to reduce the induction level. So the
Yes.
growth, I think that could be positively impacted. What about, do you have some quantitative data about this kind of choice?
Yeah, we can say noise is also an important factor for the transformer, and also it's based on at the end the final installation and application. We did not add in the study the analysis of the noise, but we can see also that same as the material trend and the load loss, everyone is looking for new materials, and these new materials need to have a lower noise at the end of the final transformer. So we can see in the trend, also we analyze internally some data, and we can see that the aim of reducing the induction is also supporting the noise level. We can see a reduction in the noise level, and everyone, even in the conventional cases, is having lower noise than 10 years ago.
Okay, thank you.
Thank you for your presentation. And in your slide, page number 15, you show the reduction of the colos in about 2027. Is that the year you expect the introduce of EU Tier 3 regulation? And in that time, do you expect more usage of E-steel thickness 0.20 or 0.80?
Yeah, that's a very interesting question. So what we can see is in Europe there is no yet defined a Tier 3 regulation, but everyone is looking for new steps of this regulation. And the idea, of course, is to reduce again the losses, but also take in account the green source of the material. So we can see from one side, of course, the idea will be to go to material with losses below 0.60 watt/kg, but at the same time we know how difficult it is to produce a low losses material and make a big step in the developments. So there is more and more the idea to take in account the origin of the material in terms of the CO2 emission, because that everyone is focused to have this net zero carbon free. So the goal will be more and more to reduce the emission, and might be that the developments of the material will not move more and more into lower losses, but more into the reduction of the carbon emission.
Understand. Thank you.
You're welcome.
In all your case studies that you presented, are those designs from the customer, or are they designs that LTC provides to the customer?
I would say no. These are all designs that are provided by customer, and this is basically an overview that we have from our own database of data. And we can see LTC is not making a design of the core, but is just producing the core of the transformer. So we can see a lot of customers having different trends, but what we summarize is the main trend.
Thank you.
You're welcome.
Ladies and gentlemen, please join me in thanking Simone for the best. Thank you.
Thank
Great
you.
stuff.
Thank you. Thank you.